Hello. So my presentation is on analyzing air pollutant concentrations over time, and I took a data set containing a bunch of different types of pollutants and decided to look at how and why this changes over time. So first of all, here's my data set, and the original data set that I had a lot of different pollutants and random information about them, and I decided to cut this down into a short, concise data set containing seven different pollutants and columns from 1970 or rows from 1970 to 2016, containing the overall emissions in the United States of these pollutants in thousands of tons. So yeah, here, if you look at that. And my hypothesis based on this was that CO2, NOx, and NH3 levels would rise slightly over time, and VOC, PM10, and PM25 levels would fall slightly over time. And this is because of policy and regulations that I priorly researched, also like the Clean Air Act, which regulates particulate matter levels. And my other hypothesis was that overall emissions would end up decreasing due to regulations, and that emission decrease would be correlated with environmental protection legislation. So if you look at the first plot, this is emissions from 1970, and you can see that CO2 is falling really, really quickly. And all of the other pollutants stayed pretty much constant. They decreased a little bit, but they didn't change that much from 1970. So that's pretty interesting to look at. And I ended up standardizing this, applying a time constraint with the iLock function because I wanted to look at a more standardized data set from 1990. And you can see a really similar thing here that CO2 decreased a lot, but everything else stayed pretty consistent. So here are the histograms that I made, and I basically used these to look at the overall concentrations of these pollutants and help calculate a sum. So I put the emissions per year into bins and looked at the overall emissions for each pollutant using a histogram. So every histogram is a different pollutant. So I made these for each one. So you can see CO2 has a lot of emissions and H3 is a little bit less. And here are the statistics that I calculated. So the main one that I was looking at was just the sum, the total emissions, and I calculated that 5.95 billion tons of pollutant were emitted since 1970, um, which is a crazy number. And the overall statistics that I looked at were just looking at like the mean, the standard deviation of these pollutants and looking at the validity of the data. And here's the emission distribution by year. So you can see in 1990, CO2 was about 65% of the overall emissions. PM10 and NOx were the next largest ones. And in 2016, you can see that CO2 has gone down a lot and PM10 is kind of taking over. And this correlates with the graph a lot because CO2 was the main pollutant that was falling a lot. So what does this tell us so far is that the concentrations of almost every pollutant decrease. I think one of them or two of them actually increased slightly, and they decreased to varying degrees, which actually did not support my hypothesis as I thought that CO2 would increase, but it decreased rapidly. And I thought particulate matter would decrease, but it actually increased. So two more questions that I wanted to ask. How much did these change and why did these change? So in order to analyze these questions, I added a rate of change column for my new column. And as you can see on the right, the CO2 change is on the left, and it was really high. One year, there was a 13% decrease in CO2. Um, and yeah, the values are really high for this rate of change. And then if you look at the NH3, for example, the values are a little bit lower, especially later on. So these really kind of evened out and didn't change as much. So I took these for every single pollutant and analyzed them. And here you can see the regressions that I did. I decided to look at these to say, why did these change? Were the policies that stop pollutants together, or did they target individual pollutants? So I looked at CO2 versus time, which was highly negatively correlated with a 0.986 R squared, which is super, super high, which shows that CO2 decrease was very significant. NH3 decrease was a lot less significant with a 0.381 R squared, and NH3 actually increased a little bit. So PM10 versus CO2 was one of the things I looked at when I was analyzing pollutants versus each other. And pretty much every single pollutant that was regressed against each other had a very low R squared. PM10 and CO2 was 0.086, which shows that regulations may have been very singular rather than overarching. And yeah, this is basically a continuation of that my hypothesis was not supported, that CO2 decreased drastically, and most pollutants did not very highly correlate with each other, suggesting that environmental regulations had an individual effect rather than an overarching effect. And regulations did seem to be more focused on CO2 removal, and clean air regulations were most focused on ozone, carbon monoxide, and CO2. Ozone and carbon monoxide were not part of this study, which makes sense that a lot of other pollutants didn't change that much because they weren't targeted as much. And then the last thing I made was just an interactive plot where you can take a slider and change the maximum year to look at how much pollutants changed between different years. So you can see here that up until 1986, CO2 decreased very highly. But then if you look at it up until 2006, CO2 decrease actually became a little bit less steep. So these are just really interesting to look at if you're looking at when the environmental regulations happened, and how they targeted it. And I made this using Jupyter, so I can add that code in. And that was another part of Anaconda, so I thought it would be really cool to explore and see how to make interactive plots. And yeah, this is my presentation. Hopefully you have a good break. Thank you.